In exercise 9b, sorry, we're moving on to look now in a different way at the parabola, where you're going to see the definition for a parabola, which probably may not have even ever been given, any sort of definition for a parabola, but the mathematical definition for a parabola is actually in terms of a point and a line. So it talks about a given point, which, by the way, is not the vertex of the parabola. It's not even on the parabola. This point they talk about is, I would describe as inside the parabola, inside the U shape. It actually sits on the axis of symmetry of the parabola, and it is referred to as the focus. The focus. Whoops. The focus. So it is about that point and, as I said before, a straight line. Now, the straight line, just in terms of its name, is called the directrix. And again, this straight line is not on the parabola anywhere. This straight line is outside the parabola. And in this course, we only look at parabolas where the directrix, which in this example is this line here, is either horizontal or vertical. We will see an example where the directrix is a vertical line. I believe, not that I've taught it, but in extension 2, you look at parabolas with an oblique directrix. So oblique just means on an angle. The directrix might be that, the focus might be this point, and your parabola then sits in between. So it's, clearly the directrix is not vertical or horizontal. It's on an angle, I guess, diagonal maybe we would call that, and more correctly it's called oblique. Okay, so back to the definition of the parabola in terms of this point and a line. So the parabola actually ends up being the set of points which are equidistant from the fixed point, which we call the focus, but for some reason, and it wasn't decided by me obviously, but for some reason it is commonly given the letter S, capital S, for the focus. And so we could find, for example, the distance between this point and, let me see if that's going to work, this point here. So that distance, and I rarely draw a parabola correctly. I rarely find the correct spot for the focus. You can see here, I've clearly that's not a realistic focal point for this parabola, because what's meant to happen is that distance there and the distance then to the directrix, they're meant to be the same. They're meant to be the same distance. Now, you can clearly see it's not like that. So maybe the real focus for that particular black-shaped parabola I've drawn, a more realistic focus might be there, and hopefully trying to get the distance between the focal point and the actual parabola equal to the distance between the parabola then and the directrix. Okay, you won't be tested on how well you can draw them, and you'll commonly see me locate the focus point in a position, unless I've been told where the focus actually is, and many of the questions will tell you the actual coordinates of the focus, which is great, and you will once you know that, it's a little bit easier for you to draw the parabola correctly. Okay, but the drawing of it is not what we're going to be focused on too much. Now, there are a lot of terms, additional terms associated. So you've already been introduced to two. You've not previously talked about a parabola having a focus, but now you have to. You haven't previously realised that a parabola has a directrix, but now you are aware of that. There are some other dimensions that you must be familiar with as well. So the things that you already know. So we already know about the axis of symmetry, and that stays the same. That's fine, our axis of symmetry. Our vertex also you're familiar with, and that has stayed the same. Now, the focus, we've just introduced the focus, and we've just introduced the, is this point here is the focus, and we've just introduced the directrix. And then amongst all of this, you've got your parabola shape, this actual parabola, this actual set of points. Now, another dimension that we haven't talked about, which is important, is this thing called the focal length. Now, the focal length is just the distance between the vertex and the focus. That is the focal length. And that's fixed. The focal length is a fixed value. So the focus doesn't keep moving. That point S is fixed for this particular set of points. So the focal length is fixed. What we do know is that the vertex always sits right in the middle between the focus and the directrix. It sits in the middle of the focus and the directrix. So you will see that the focal length, the letter used is a lowercase a, and so the distance from the vertex to the focus is this lowercase a. The distance then from the vertex to the directrix is also an a. So if we're going from the focus down to the directrix, so this is the focus, then we know that total distance there is 2a. 2a. Now, what the definition says for a parabola is the distance from the focus to the parabola should be the same distance as the parabola to the directrix. Now you can see that my diagram is not to scale. It is not accurate. What we do know is that length there is 2a, because from the focus to the directrix, this is a, and then this is a, because the vertex sits in the middle, right exactly in the middle between the focus and the directrix, and hence this distance would be 2a, and so this distance is 2a, and that only becomes important when we look finally at our last new term, which is the latus rectum, which is the distance right across. The latus rectum is this special chord. A chord will join 2 points. So I'm going from this point on the parabola over to this point on the parabola. A chord passing through the focus that is parallel. That's the really important feature. This is parallel to the directrix. because it's possible to draw a chord going through another chord, going through the focus that joins 2 points. So this random point through the focus out to here. Oops, didn't draw. Let me try that again. So let's say I'm going here through the focus and out up here to join, right, parabola. So that's also a focal chord. That would be called a focal chord. Just know, chords join 2 points, and it's called a focal chord because it goes through the focus, goes through S. So we don't know anything in particular about that focal chord at the moment, but back to this one that I drew here and highlighted in green is the actual latus rectum. It is a focal chord, but it has a particular name called the latus rectum, and its total length is 4 times the focal length, which is your little a. The distance from the focus to the directrix is actually 2a, isn't it? Because did it actually state the length of the definition for A? The letter A is used to denote it as the focal length. Should really highlight that a bit more. A is used for the focal length, and the focal length was, remember, this distance between the focus and the vertex is the focal length. Okay, so there's quite a lot of new terms there. I'm going to stop the video and just call this the introduction to your mathematical definition of the parabola, and yeah, you can rewind and go through those concepts as often as you like, and maybe pick up some other things that I've written there. And in particular, this, an interval joining 2 points on the parabola, is called a chord. A chord that passes through the focus is a focal chord. The latus rectum is a unique focal chord because it is parallel to the directrix. Yeah, I wouldn't be surprised if you felt like you needed to listen to this entire video again, just to consolidate those concepts.